university, okay? In that coin tossing experiment, what I had here, HH, HT, TH, TT, HH, HT, TH, and TT. This is what I wrote. And then I put here X equal to number of heads. X equal to number of heads I put. And then X is a random variable. Then there is a 4 head, 3 head, 3 head, 2 head, 3 head, 2 head, 2 head, 1 head. 3 head, 2 head, 2 head, 1 head. And then 2 head, 1 head, 1 head, 0 head. You remember that, right? And then I say to you, instead of tossing the coin 4 times, I want to toss the coin 10 times. You remember? Then how can you find the probability of getting exactly 7 head? You remember? 10 times means how many sample points? 2 to the power 10, which is equal to 1032, right? Right? Can I write all of these sample points? I can, but it will take almost half of the day, right? Yes. 24. 1024. It will take half of my day, right? So our forefather gave a formula to compute this type of probability by using binomial distribution that I just wrote, okay? Okay, how do you know a problem is a binomial problem? Number of trials is fixed, okay? And number of successes is fixed. Number of trials is fixed means a coin is tossed 10 times. So 10 times is fixed, okay? A hospital has 30 patients, fixed. Are you understanding? A university has 40 players, fixed. Okay, so number of trials must be fixed, because in your exam, how do you know this is a binomial problem? Because other distributions are coming. Number of trials must be fixed. Okay, so now let us solve a problem. Let us solve a problem. Isabel and Tyler, are you okay? Are you understanding?
Yes.
Yes. How about Tyler? Okay. Now let me solve a problem, okay? So you understand when binomial distribution is appropriate. So I give you a small scale example for coin tossing, which we can easily do by constructing sample space and counting the sample points and then find the probability. Find the probability of exactly 3 head, exactly 4 head, exactly 2 head, at least 1 head, at least 3 head, which could be easily obtained by counting the sample points in the sample space. But if we have number of trials large, very big, we cannot do these things. So in that case, we have to use a formula known as binomial formula. Clear? So with this one, you can also write mean of the binomial. Here you can write mean is NP and variance equal to NPQ. Okay, mean and variance of the two things, mean and variance. Okay, NPQ. The materials that I'm covering, I already uploaded a PDF file on the Western Online. Okay, now let us solve a problem, then we are done with the binomial distribution. A hospital has 20 patients. Okay. Probability of a COVID patient is 0.24. Okay. Find the probability that The hospital as number one, exactly 7 COVID patients. Okay? Yes.
Find the second sentence probability. Why? That's what it's called.
This one,
Yeah.
it's called probability of a COVID patient. Shortcut version of probability.
Oh,
That is why I write like probability. I write probability like this way and distribution like this way. Okay? I don't have a lot of time.
that's it, so long.
Okay? Exactly 7 COVID patients. Okay? So as computer and Python is available, it is just one line of code. Okay? So, but suppose there is no computer and you are born and you are now in school in 1995 or 1996. Okay? How can you solve this? You will solve this probability of x equal to 7. Okay? You are solving now in 1995 or 1996. Okay? X equal to 7. 20, choose 7. Probability of a COVID patient is 20.24 to the power 7. 1 minus 0.24 to the power 20 minus 7. That's the way we solved it. Understand? That's the way we solve it. But how can you solve it? Okay, let us solve it by manual approach as well as by Python. Okay, so let me solve it manually. Let me open the R. Where is my R? Here is my R. Here is my R. And then I will go to the Python. Okay, just be patient. I will go by the Python as well. Let me open the Python. Here is the Python is opening. So let me open is choose 20, choose 7. Okay, and then times 0.24. I want to put here 0.24 to the power 7. Okay, then I want to put here 1 minus 0.24. 1 minus 0.24 equal to 0.76. 0.76 to the power 20 minus 7 equal to 13. 13. Okay? What? Okay, I understand where I made the mistakes. So 0.100.1003389. The answer is 0.1003389. 3389. Okay? Clear, right? Now, how can you solve this problem in your exam? Very quick, one line of R code, but you have to understand, right? So let me show you the R code. Let me take you to that Western Online. Here is the D2L. Here is the D2L. There is the content, probability distribution. Okay. Okay, let me download it. Are you seeing? This is the code. So I just copies this thing and open it in here and just want to open a new file, and just want to. Okay. So now let me run this one first. Control enter. View. Windows layout. So this is the way. Now I have to consider here 7 and 20. 7 and 20, and then I have to consider here 24. 24. Okay? You can see it, right? Okay. So let me run it and see whether we will get the same thing or not. Just run it. 0.10003388, right? Clear, right? Clear, right? So you do not need to do all of those nasty hand and calculator computation, okay? You just do Python, right? You just do the Python. Yes,
There's also a way to do it.
I know, okay?
Pretty much the same thing.
Yeah, that is why the Texas instrument was developed to do scientific calculation, and it came to the market. Scientific calculator came to the market in 1971 or 72, something like that, before that. So one problem is gone, right? Exactly 7 COVID patients. Now I want to do at most 8 COVID patient. It is the finding the probability at most 8 COVID patients. See, I clearly wrote, find the probability that the hospital has, right? So at most 8 COVID patients. At most 8 COVID patients. So how can you do that? Probability of X less equal to 8. So which we can write here. Let me go and copy it from there. At most states.binom.cdf. States.binom.cdf. You can write here states.binom.cdf 8 out of 20 with probability 0.24. That is the answer. Okay. Let me see. We need to come here and change it. CDF, and then we need to change 7 to 8 and 20 and 0.24. The answer is 0.96. Okay. Can you see the Python output from the back? Can you see this? You can see the code, but you cannot. So there is a way to do this. I think edit. Let me see, edit. There is a way to do that. Let me see, edit. Maximize current plan, toolbars. No, there is a console, something console. Here. I don't know. I tried. I did not find it. Now let me do number 3. At least 15 COVID patient. At least 15 COVID patient means X greater equal to 15, right? Which could be written as 1 minus probability of X less equal to 14. Do you understand these things? Do you understand these things? At least 15 minus 1 minus less than at most 14. Okay? At most 14. And then it could be written like 1 minus stats dot binom dot CDF dot 14 20 to 4. Okay. Online people, are you understanding? Tyler and Isabella, are you okay?
Yes.
Good. And then number 4, find number 4, find the mean number of COVID patient. Average COVID patients in the hospital. Okay. So N times P, N equal to 20, and this is 24, 4.8. I finished binomial distribution in 22 minutes. Clear? Okay, before going to the next one, listen carefully. In your exam, there will be a problem from binomial, negative binomial, geometric, Poisson, normal. How many? 5. 5 finger, okay? Only for the normal distribution, I have to specify in the question the data follow normal distributions. Are you understanding? But 4 other distributions, I must not. I do not need to tell that data follow binomial, negative binomial, geometric, or Poisson. I must not. By reading the question, you have to decide. Understand? Very important things that I'm telling now. There will be 2 exams on the probability. Okay? One already I covered. One already I covered, and today I am covering probability distribution. Clear, right? How many probability distributions I am discussing? 5. Only normal distributions in the questions, the word normal distribution must be written. Clear, right? And other 4 distributions, binomial, Poisson, geometric, negative binomial distributions, there is no mention of these distributions. You have to read the question and you have to understand what distributions you are going to apply. Clear? Clear, everyone? So now, how do you know a problem is a binomial problem? Number of trials is fixed, number of successes is fixed, right? A hospital has 20 patients. A university has 40 sportsmen. Okay. A university has 33 professors. Okay. A university has 20 nurses. Understand? And find the probability that among the 20 nurses, 7 of them graduated from Western Illinois University. The probability of graduating from Western Illinois University is 0.3. Understand, right? Okay. So now you understand when to use binomial distribution. Now I am going for geometric distribution. Geometric distribution. Okay. Every human being on their life is pursuing geometric distribution. Understand what I said? Every human being. Now what are your target? Your target is now to get an internship or job, right? Most of the time in our life, we are happy with one success. What? One college admission, one job, one new car, one home, one spouse. Do you understand what I said? Most of the time, we are happy with only one success. Only one success. By reading the question, if you see that there is a series of failure before getting the first success, then it is geometric distribution. Understand? Do you understand? Understand? Suppose this gentleman, just for making fun, I am telling, he is proposing girls after girls after girls for getting married. So he got his spouse at seventh proposal. Understand? So how many failures? Understand? And you are interviewing for the job again and again and again. You give the 12 interview, but you got the job in the 13th interview. So how many failure? Understand? You are trying to buy a home, you with the realtor, visiting home one after another, something you like, some other thing your wife does not like. Okay, when we are shopping home, same thing happen. I like a big backyard, but my wife like a very big, beautiful kitchen. Understand? So most of the time in our life, we are happy with only one success that is achieved after a lot of failure. But if you get it at the first success, then there is no failure. That is also possibility. Okay. Take a look at the mathematical formula. Mathematical formula is this. One success, rest of them is failure. Okay. One success and rest of them is a failure. X equal to what? Number of trials. Number of trials. Trials. Clear, right? Now suppose I am tossing a die. I got a 6 at my 5th trial. Are you understanding? I am tossing a die. I got the failure. Q means failure. I got the number 6 at 5th. First one failure, second one failure, third one failure, fourth one failure, and 5th one I got the success. Understand? 5th one I get the success. Now I want to write it in that format. P q to the power 5 minus 1. Are you seeing how did I write it? Are you seeing that? Are you seeing that? Okay. Again, before going to the problem, let me write the mean, and P is the probability of success. P equal to probability of success. Q equal to probability of failure. Q equal to 1 minus P. Mean equal to Q over P. Variance equal to Q over P square. Okay?
What is A?
There is no A. I never write A like this format. Which one is A?
There is.
This is? This is?
That's Q.
That is very beautiful Q. Suppose a person throw a pair die. Find the probability that he got a 6 at 7th try. Okay? How can I solve it? Probability of x equal to 7. Probability of getting a 6 is 1 over 6. Probability of getting a non-6 is 5 over 6 to the power 7 minus 1. Right? Just copy and paste from there. These things I just copy and paste it in there. That is the answer.
Wait, a person, find the probability that he got a 6 what?
He got a 6 at 7th try. At 7th try. So probability of getting 6 is what? 1/6, right? Lara,
Yes,
1/6. And probability of not getting a 6? 5/6. Do you understand why 5/6? So that's the answer. So now find the mean number of trials. Find the mean number of trials to get. Find the mean number of trials to get a 6 when the die was tossed 7th time. What should I do? Mean equal to Q over P. Q equal to 5/6. P equal to 1/6. On an average 5 time you have to throw the die. This is average means in long term. First time you can get at 8th try, second time, second try, third time you can get in 5th try, fourth time you can get in first try. You understand? It is a long run situation on an average situation. Uh-oh,
thank you.
good. Now I'm going to start negative binomial. So what I am discussing, I very beautifully wrote these things in the PDF file. Okay, take the printout, sleep in your couch and read these things attentively. Yeah, but if you want to read it online, that is also fine. Now, negative binomial distribution. The mathematical formula is this. X equal to X, X plus R minus 1, C R minus 1, P to the power R, Q to the power X. These are all multiplication. These are all multiplication. Okay? These are all multiplication. X takes value 0, 1, 2, up to infinity. Did I write here? Okay. So here, X equal to 0, 1, 2, up to infinity. Sorry, X equal to 1. 1 to up to infinity. I forgot to write the values of the X. Because you can continue the trial, right? And you can never get a 6. There is at least chance you will never get a 6, you can continue the trial. So the geometric distributions 1 to up to infinity. Understand, right? This is what I did not write before. Now I wrote geometric distribution X takes value 1, 2, 3 up to infinity. Now this is negative binomial distribution. Okay, I have to explain each of these, okay? Can anyone of you tell me what is this? What is that? No, I want to know this. You remember the computational method that I taught? What is this? Is combination. Okay? It is combination. It's combination. It's combination, but now I have to explain what is X. X equal to number of failures. Number of failures are equal to number of successes. X plus R equal to total number of trials P equal to probability of success, Q equal to 1 minus P equal to probability of failure. Okay? Clear, right? Yes.
So how would you read the form?
X plus R minus 1 combination R minus 1 times P to the power R times Q to the power X. These are all multiplication, okay? Okay. What is the mean? Mean equal to RQ over P and variance equal to RQ over P square. Okay? Real life example. Real life example, okay? RQ over P square. Mean and variance. Question? Question what?
The last line, Q equals what?
Q equal 1 minus P. Probability of failure. Q equal to probability of failure and P equal to probability of success. Ready? Suppose this boy invited me at his home for dinner.
He invited you?
Yeah,
Oh, okay. I heard something.
he invited me at his home for dinner, but I said that I can come with my wife and 2 daughters. He said, okay, it's all right, come. And he further asked me, what do you like to eat in the dinner? I said that I like salmon fish very much. He said, well, I can catch it because I live in Seattle, there are a lot of salmon fish. So his target is to catch, because 4 of us, right? Geometric distribution is only one success. Negative binomial distribution, he put his angler up until he got 4 salmon fishes. So first time he put, the clever fish took away the bait. Second time he got the success. Third time took away. Fourth time took away. Fifth time he got the success. In this way, he caught 4 salmon fishes at 17th try. How many failure? 30. Are you understanding? Instead of one success, if we are pursuing to obtain a specific number of success, then it will be a negative binomial distribution. Understand, right? No? You understand or no? Okay. So take a look at that. I explain you what is binomial distributions. Number of trial is fixed. A hospital has 20 patients. A university has 15 athletes. A community has 20 soccer players. Understand? So total number of trial is fixed and also number of success is a fixed. That is what you are finding. This is called the binomial. And geometric, you are looking for only one success. On the other hand is negative binomial, you are looking for a specific number of successes. So he invited me and now his purpose is to catch 4 fishes. Myself, my wife, my 2 daughters. Right? 4 fishes. So in the negative binomial, you will see the word until or up until. So suppose the problem that I have written in your PDF sheet, you will see there. Let me write it here so you will understand. Problem. An oil company is digging well for fossil fuel. Okay? For fossil fuel, a oil company is digging oil for fossil fuel. The probability of getting fossil fuel from the well is 0.17. Find the probability that the company will get oil from fourth well when they dug 17th Do you understand the question? They will get oil from the fourth well. So that means first, second, third, fourth, it is already got. They already got first, second, third. This is their fourth one. But fourth one they will get at the 17th well.
How many wells are there?
Altogether 17.
And they got oil.
Fourth one. So that means 13 failure. Clear, right? So remember, when you solve the problem, you have to be well acquainted the circumstances. You have to use these probability distributions. My experience is telling me people mess up negative binomial with the binomial. They do not mess up the geometric one because that is only one success. Understand, right? You have question? So now if I want to solve it, our P equal to what? P equal to 0.17 and Q equal to 0.83. So now probability of X equal to X equal to what? Number of failures, right? 13. And then 13 plus 4 minus 1, C 4 minus 1, P to the power R, which is equal to 4, Q to the power X, which is equal to 13. Exactly this formula. Take a look. Exactly that formula. Here X equal to number of failures. Right? So there is a formula. Let me directly write the formula from here. States and binom PMF. States and binom PMF. So we can write here states and binom PMF. What was that problem? 3 successes and failure. First failure will come. So I should put here 13, 4, and probability of success is 0.17. That is the answer. You can write this Python code, okay? I have to save some time, okay? I am not going to discuss this thing. So find the mean number of failures to get four successes, which is RQ over P are equal to what? 4, Q equal to 83, P equal to 0.7. Mean numbers of failure. Find the mean number of failures to get 4 successes. Yes. This one, right? 19.5. Okay. Again, this is in a long run situation. Average means in a long run. Sometimes you need to have a 25 failures, 30 failures. Some other time you have to have a 7 failure or 8 failure. Understand? You have to understand this. This is a long run situation. And these are all mathematically derived. If you say that, hey, professor, you are writing some number RQ over P, how can I believe you? We don't believe you. If you say these things, I can derive these things mathematically. Understand? So I write mean equal to NP for the binomial. That is a derivations. And then variance equal to NPQ. That is a derivation directly coming from distribution. For example, just one line I want to show you. If you want me to derive this thing, expected value of X, I can write here X and then N C X, P to the power X, Q to the power N minus X. And then I can break it and then match something in here. I can derive eat that NP, okay? So let me see if at the end of the class, if I have 5 to 7 minutes, I will derive this for you in order to convince you, understand? Yes, gentlemen.
So the mean is going to be a decimal,
Yeah.
but when we're interpreting the results, like say I want to present my findings to a company that says, hey, so how many wells are we gonna have to go through to get 4 successes? I'm not gonna tell them, you're gonna have to go through 19 and a half wells, because they can't go through half. So I would interpret that as saying we go through approximately 20 wells.
Yeah, exactly.
Is that how you want?
Yeah. Approximately 20, and then theoretically it is coming 19.5, but practically we cannot do 0.53, right?
So what do you want to see when we answer that question?
This one,
Because
you can say 19 or 20. It's 19.5, either you can say 19 or 20.
way to interpret this problem, see that multiple successes, even though that there's gonna be a specified end amount of trials. Like how it says that by the 1712, the oil company will get that 412.
So they have a specific target from the very beginning.
Okay,
Understand?
that's their specific goal.
Yeah.
17, and then, okay, I just wanna make sure so that when I'm looking at it, like on an exam or something, I know how to interpret it.
No, geometric distribution means we are looking for a specific number of success. And then that is coming from trial one after another one. It is not like all 17 at a time, no. That is binomial, fixed trial. And here you do not know. After data coming, then it is in your hand, but data is coming in the format of a negative binomial. You are searching for 4 successes. Okay, at the end of the class, yeah, if I have 10 to 15 minutes, I derive these things, okay, mathematically. In order to convince you that I did not write some of this mathematical formula as an expression for the mean and variance by myself. Yes, Lara?
So, I think that we can also do the formula.
Yes, that will save you time. Unless you like, no, I don't believe Python, I want to compute everything by solid method, paper and pencil and calculator. That you also have a option to do that. Okay? You are writing down this code, right?
Yes.
This Python code. And I showed you one. Take a look at that. I showed you one. I cannot show you more because it will be a waste of time. Okay, let me start another distribution. Poisson distribution. Poisson. Okay. What is the mathematical formula? This is the mathematical formula. Uh-oh. Better to write it as events. Mean, that means average equal to lambda, variance also equal to lambda. Only distributions that has the same mean and variance. Only distributions that has the same mean and variance. Yes.
What is the formula?
Probability of x equal to x equal to e to the power minus lambda. It is known as lambda. You will give it like this, and then you will like that. And it has a name lambda. Is this what you are seeing first time? Okay. I must be very happy because I show you something first time in your life. Now he knows all of these things. He's a mathematics guy. Okay, lambda is a Greek letter. T like this, right? That's a good thing.
More like a backwards upside down, like a inverted line. It's more like a backwards S with a kickstand.
What else?
What?
Okay, so now let me write a problem, okay? Okay, okay, you finish writing, then I want to tell something.
The variance is minus.
No, just lambda. Equal. So this is the only probability distributions that has the same mean and variance. Clear? Only probability distributions that has the same mean and variance. Only probability distribution that has the same mean and variance. Could you say that again?
Is it the only one that had the same mean and variance?
Yes.
as the 5 we're rating? Or just
Yeah.
one that-
This is just the only probability distributions that has the same mean and variance. Binomial has different mean and variance. Geometric has different mean and variance.
Right.
Negative binomial has different mean and variance. And also normal distribution that is coming also has a different mean and variance. But Poisson distribution is the only distributions that has the same mean and variance. Clear?
Yes.
Or,
I was wondering if it was out of the 5 that we're learning
yeah,
or out of all of them.
out of the all, out of the all. There are many other probability distributions out of the all.
That's why I was curious.
There are a lot of like hypergeometric distributions, uniform distributions, and then chi-square, and then gamma distribution, beta distribution, exponential distribution, double exponential distribution, log normal distributions, different. Okay? A problem. Okay, now let me explain this thing. This is the binomial distribution, how this distribution come. NCX, P to the power X, Q to the power N minus X. From there, these things applied. N goes to infinity and NP equal to lambda. So P equal to lambda over N and P goes to 0. Under this condition number 1, condition number 2, and condition number 3. 1, 2, 3. We got Poisson distribution. Okay. This distribution, like one day someone wake up from the sleeping and then he write these things, he said that this is the distribution. No, it did not happen like that way. Understand, right? There is a binomial distribution. On the binomial distribution, some limiting conditions are applied, then this was developed. Okay? From this, we go to that under these 3 conditions. Clear, right? It is a mathematical derivation. It is not someone in the morning wake up and write a formula and then say that this is a probability distribution. Okay. Clear, right? Okay, do you have any question at this time? I want a question from you. I have written mathematical formula as well as their real life applications. For each of these problem, I'm giving you a real life application, right? You have seen that, right? In the exam, you will see this type of problem, but immediately you have to read the problem and have to figure out what distributions you are going to use. Remember these things. Now, if you ask me this question, when a function is said to be probability distribution, do you understand? I have written so far 4 probability distribution, right? How many I have written? 4, right? Binomial, negative binomial, geometric Poisson, right? 4. So that means take a look at that. If someone tell you that this is a probability distribution function, listen carefully. Someone tell you this is a probability distribution function, probability distributions, then it must satisfy 2 conditions. One is it is always positive. It is always positive. Another one is sum or integration of the probability function is always equal to 1. If these 2 conditions is satisfied, any mathematical function will be called as a probability distribution. Are you understanding what I said? Someone tell you this is a probability distribution. Then what would be your question? Does it satisfy these 2 conditions? That means, is it always positive? Second thing is that sum up to 1? You understand? If I give you a mathematical function, understand? I said that it is probability distribution. Then what will be your question? Your question will be, does your function satisfy these 2 conditions? It is always positive. That means whatever value you plug, it will give you a positive number. And sum up to 1. Clear? Okay. So now I am going to solve a problem using Poisson distribution. At Macomb railway intersection, the accident rate is 3. Okay? Accident rate is 3
Per,
per day, suppose something like that.
that's bad intersection.
How many cars passes by that in all 24 hours? Maybe 100,000 altogether?
That's big.
No, because that is the place. People are always coming, going. 100,000 is acceptable, I guess. No?
Maybe 20. Also,
Okay, so find the probability that in a particular day there is an exact 4 accidents. Understand? How many? 4. So I can write probability of x equal to 4 then e to the power minus lambda, which is equal to 3, lambda to the power 3 to the power 4, factorial 4. Okay? That's the way you can solve it. Did I write that code? Did I write the Poisson code? Let me see. Yeah, Poisson PMF, 5 accident, 3. Poisson PMF, Poisson.pmf 5,3. Poisson.pmf, Poisson.pmf 5,3. That is the answer. Understand? Clear, right? Okay. So far I have discussed how many probability distributions? 4. Yes.
Does something not be specific? Says Poisson is not.
Is not?
Yeah,
Did I write something in there?
maybe it's missing stop Poisson.
Or Poisson PMF is not working?
Yeah, you've got the stats.
Yeah. If you start in front of it is working, right?
Yeah.
Okay. Thank you for figuring out stats. Thank you.
On the quote is,
Yeah, you have to have stats in front. On the document you gave, it doesn't have stats.
On the documents, I forgot to put stats. Okay? Okay. Take like 5 to 7 minutes break, then we will start normal distribution. Okay? It's a big distribution, sir. Altogether, how many problems? Around 15 different types of problems. Let me drink some water. I have recorded the class, I will upload it, okay? Is in recording. Okay, normal distribution. Okay, mathematical formula, there are two types of normal distribution. One is standard normal distribution, which is a mathematical form, is this. Z square. And there is a normal distribution also, which is a mathematical form. Okay. This is the continuous distribution. You do not need to memorize any of this probability distribution. I'm just showing you how the mathematical form looks like, okay? Now I'm going to solve one after another, altogether maybe 15 different problems, 15 to 16 different problems by using this. Clear? Take a look at that. Are you? So this one has a mean equal to mu and standard deviation equal to sigma. Okay? And that one has a mean equal to 0, standard deviation equal to 1. Did you lose something? So now the final distribution, fifth distribution known as the normal distribution is going to be discussed. So normal distribution has two types. One is standard normal distribution, another one is just normal distribution. Clear? Clear, right? So normal distribution has two types. One is standard normal distribution, which has a mean 0 and standard deviation 1. And normal distribution has a mean mu, standard deviation sigma. Clear, right? Now I'm going to solve this problem, then you will understand. What I am solving, what I am discussing today, all of these things you will find in this 7-page document. Understand? In this 7-page document, all of these things you will find, okay? This document is in the online, okay? Okay, let me start. First of all, I want to find this probability of z less than equal to -1. I want to find this. Okay. So z less than equal to -1. If you ask me to draw the figure is this. Okay. Right? Now I want to show you the normal table. Yes. Are you seeing normal table in here? Take a look at the board. Take a look at the board. Take a look. -1, right? I said -1, right? Are you seeing -1 in there? -1. Okay. -1 and then 0, right? Right? See, this is z, this is this one is z, this one is also z. I want less than -1. So less than -1. Are you seeing the value is 0.15866? Are you seeing the value is this? Do you see that? See that, right? less than negative. Okay, so this is 0.15866. Clear? But how can I find it by using Python? How can I find it by using Python? That is what, if I want to get it, where is my that document? I closed it already. I have to write this code. States norm.cdf. I have to write here. Let me write here. States dot norm dot cdf -1 0,1. What does that 0 and that 1 stands for? Mean and standard deviation. Okay, so let me run these things in Python. Let me run this in the Python. State dot norm dot cdf, and then I want to put here -1 0,1 and control enter. See, I got 0.15866, right? So now there is a software, R, Python, Excel, you can use, you can compute these things. But when we are students, our professor give us this table. Our professor gave us this table. And this table. Computer was very expensive during that times. In mid-90s, late 90s, very expensive. A simple desktop computer was around $1,000 or more than that. But now with the $300, we can buy a laptop, right? $300, $400. Okay, so you got it, right? I'm not going to discuss this table anymore, but if you want, you can try this one. Rest of the thing, I will just use the technology. So this is the first problem is gone. Second problem, I am going to do probability of z less than 1. Probability of z less than 1 equal to which one? Like this, like that. This is equal to 1. Okay. So what I can do it in here, it is just state norm dot cdf 1, 0, 1. Then what are you going to get it in here? You will get it in here 0.85 no 84. Let me see, this is equal to 4 7 3, it is 1 and 6 10 8 2 8. This is okay. So how can you compute this? You just go there. Bring it in here, change -1 to +1 and hit enter, you will get this result. Okay. Less than 2 is done. Now greater than 2. Probability of z greater than -1, which is equal to, this is -1, but I want to find this area. I want to find this probability or area or the percentage of frequency. Percentage of frequency. which is equal to, see, these two things are exactly same thing. Let me clarify this thing. So if I want to write it in here, this is 1. This area and that area are the same. Okay? So I am finding this area now. I am finding now this area, which is exactly equal to that area. That area we already find in there. So which is equal to 0.84134. I think online people cannot see it. Maybe let me write it by black. 0.84134. 134. Okay? So greater than 1, you can find equal to 1 minus z less equal to 1. Anytime any greater than, you can find it by less than. Understand? Anytime any greater than, you can find it by the less than. So now if you ask me to find this one, z greater than 1, the figure for z greater than 1 is this. Okay? So in order to find this, how about if I subtract this one, if we subtract this one from 1, if this is subtracted from 1, then I will get this one. Okay? Take a look at this one. This is very important to understand. Are you looking? Take a look at that. Total area under this bell-shaped curve above this horizontal line equal to 1. Understand? Total area under this bell-shaped curve above this horizontal line equal to 1. So now, if I am asked to find this one, I am asked to find this black part, black shaded part, then if I subtract the red one from 1, then I will get black. So this is equal to probability of z less than equal to 1. Okay? So now, which is equal to 0.15866 that I already found. Now question number 5. I want to find this one. Probability of z 2 less than -2. I want to find this. So this is equal to like this. This is equal to 0. This is equal to 2. This is equal to -2. I want to find this area. Okay. So how can I find that? This could be obtained probability of z less than 2 minus probability of z less than -2. Then these things could be obtained by states dot norm dot CDF, and then you can put here 2, 0, 1 minus states dot norm dot CDF minus 2, 0, 1. That's the way you can find it. So similarly, I can find only negative part -2 less than z minus 1. Only negative part, which will be like this. States dot norm dot CDF dot -1, 0, 1 minus states dot norm dot CDF and -2, 0, 1. And number 7, I want to do everything 1 less than z less than 2. Okay. If I am asked to find these things, which is could be this is equal to 1, this is equal to 2. I want to find this area, percentage, probability, or number of frequency, percentage of frequency, which could be done is states dot norm dot CDF 2, 0, 1 states dot norm dot CDF dot 1, 0, 1. Now I want to explain something opposite. Opposite means what? Listen, now opposite type of problem I will discuss. Total area under this bell-shaped curve above this horizontal line equal to 100%. That means 1, right? 1. How did I get this bell-shaped curve? Can anyone of you tell me? The question is, how did I get this bell-shaped curve? Yes. Good, nice. I have a data is given. From that data, I constructed histogram and then at the top middle point of each bar, I got this curve. Understand? That is why this is called the frequency curve, because I have each class interval, I have frequency, then I have the bar, I add the top middle point. Thank you. Now, in this case, this is 100% frequency is in there, so that is why it is called 100% area. Okay. Now see what in this value it is called the z value. It is called the z value. In this line, what is in here? It is known as the z value. Z. This is negative, these are the positive. Okay. Now, all the problems that we did, we consider Z greater than, Z less than, Z between. Understand? But now I want to find this thing. Suppose these things is given. These things is given 0.13. I want to find this Z value. Do you understand? Now, this area is given and I want to find the Z value. This is called the opposite or inverse problem. Are you understanding what I said? So let me write it like this way. Probability of Z greater equal to A equal to 0.13. This Z equal to A, suppose. This Z value, this dot, this Z value equal to A. I want to say probability of Z greater than A, which is equal to this. I was given that percentage. How can I find the A? Okay, tell me.
You can find that value of the Z table and sit on this one.
Yes. I can find that 0.13 in the Z table, right? And then corresponding to 0.13, I can find the Z value, which is equal to A. Understand? But you have better options. If you know the Python code, one line of code, that will give you very quickly. Okay? So let me go to her approach first so that we can discuss. I said 0.13, right? Point 0.13, 0.13, 0.13, 0.13, 24, 924, 1.3, 924. I think this is the closest one. Right?
Just, do between.
This is the closest one, right? Corresponding to 0.13.
Sure.
This is the closest one, right? So this is the closest one. What is the value? Negative 1.10123. Negative 1.13. Understand? Are you okay?
I would have said 1.25.
You want to say negative 1.25. Okay. Negative 1.125. Okay, I understand what you said. Okay, that could also be acceptable. But see, this is called the inverse problem. Understand? Previously, we look at in there and found these values. Now we are looking at in here and finding these values. Clear? Clear, right? So now our value is negative 1.1. So by looking at the table, by looking at the Z table, we get A equal to 1.125. There was a negative. Why there is not a negative? Table there is a negative, right? Table there is a negative, right? Right? Table there is a negative. Why there is not a negative? Because I am looking on the table, I am looking in here. This area and that area, these 13% and that 13% is the same. Understand? Speak up. These 13% and that 13% are the same, right? But in the question, I am asking you this one. So this one equal to, so that is why this become positive, so it should be negative sign will be gone. You understand, right? And if you want to do this by using Python, let me go that part. This one, state.norm PPF. State.norm PPF. The state.norm PPF. Take a look what I am writing. I'm writing state.norm PPF .87. Are you seeing 1.126? In the question, I say 13%, right? But what did I put there? 87%, right? Do you understand? In the question, I said 13%. This is the 13%. If this is 13%, how much is in there? Understand? Because table was computed in that format. So there will be two exam on probability. One on the probability that I finished last class, and another probability to the distribution I'm discussing. That is the heart of any statistics. There is a Poisson regression, there is a negative binomial regression, there is a normal regression. Understand? You understand these things, right? Cool. Now, if I ask you to do these things, what is the meaning of this? And what is the meaning? Can anyone of you among these five, can anyone of you come to here and draw the graph of this? Z greater than 1, Z less equal to 1. This is absolute, right? What does these two line stands for? This is called absolute sign, right? I want to take out absolute signs from there. How does it look like? I want to take absolute signs from there. How does this equation look like? Do you understand? Can you write this?
Take out the absolute.
Yeah, absolute value, and then how the equation will be changed then. I want to take out absolute sign, then how it will look like. Same.
C is greater than.
Okay.
It may be like negative C and positive C.
Can you draw it? Okay. Never forget what I'm going to discuss now, okay? When you take absolute signs from there, when you take out absolute signs from there, okay? When you take out absolute signs from there, you have to write it Z greater than 1 and Z less than -1. Understand? When you take out absolute signs from there, it look like. Understand? Let me rewrite these things again. Absolute Z greater equal to 1 means Z greater than 1 or Z less than -1. And absolute z less equal to 1, when you take out the absolute sign, z look like this. Z look like this. Understand? So now, if this is the real line, here is the 0. This is what? -1 to +1. This is the absolute z less equal to 1. Understand? Write it down. Never forget these things and teach it to your younger brother and sisters. Clear, right? On the other hand, this one is here. This one is here. This red one is in there. Clear? So that means if someone will ask you, could you explain me what is the meaning of this? Absolute z greater equal to 1 plus absolute z less equal to 1. So this means this entire line. You will say this means this entire real line. Okay, entire line. Clear, right? So the reason I write it, because if I give you this type of problem in the exam, don't immediately fall from the sky. Probability of absolute z greater equal to 1.2. Understand? Then what you will have to find for this type of things, you have to draw the graph like this. This is 1.2 and that is -1.2. This is like this. This is like that. Okay? So you have to find these two things from the table. How can you find this? If you ask me to write this in the Python code, you can write here states dot norms dot cdf -1.20, 1. Okay? This is what you have found, that times 2, because this and that are the same, right? Right? Do you know the why I did it times 2? Same. Similarly, if you are asked to compute these things, what you will do? Less than 2, here is 2, here is -2. So this is what you can find. You can write states dot norm dot cdf to 0, 1 minus states dot norm dot cdf minus 2, 0, 1. So now I want you to solve this problem. 2 less than z less than a equal to 0.07. So if you want me to draw the graph, I can draw the graph for you. This is 2, this is A, and that is equal to given 0.07. Now find the value of A. Do you understand? Find the value of A. I want to give you how many minutes? I want to give you 7 minutes. Then remaining 30 minutes, I will solve another problem. Seven minutes. Low. Find the value of A.
I have a question.
Yes.
You have to define sets before you figure it out.
What was the question? It was. The question was this, right? Probability of 2 less than z less than a equal to 0.07, right?
Yeah.
You have to find what is a. What is a? How can you find the value of a? Did you get it? Okay, first of all, find this area. That is easy, right? What is that? Point 93? No, just this one. I want just these things. Two or less. What is that? What? What is that? Could you tell me? This is right. Do you agree with that? 0.97725, right? 0.97725. This is my 0.99725. Point, oh, 0.9. 0.97725, right? Plus 0.00007, right? No. What is that? 0.07000, right? Which is equal to 5274. There is a problem, right?
Yeah, it's crazy. So is it impossible to solve?
It is greater than 1. So you understand that why did I make the mistake? So how can I solve this problem? If I turn it to 0, then it will work, right? Let me go there. If I come in there, 0.02000. Now this is 0.02. Now if you add this 52799. Clear? So now this area, let me take a different color. This area equal to that area. Clear? Clear? So now come in here. This area I can write here A equal to states norm CDF 0.99725, 1 will give you the value of the A.
That's my question. On the code, we have to define what is stats.
Yeah, you have to define states in here. Let me show you. Are you seeing the line number 1?
Oh,
These are all in the code that I have provided. It is mentioned in there. So let me see if it is mentioned in there. Yeah, you have to mention that code in there. Okay.
it's not there, right?
No, it is not in there. So write it down. In the PDF file, it is not in there. Did you write it down? Because you need it for your exam.
So when do I know when to use the binomial and when to use the rule? Is that rule?
Binomial is for binomial. Norm is for normal. Poisson is for Poisson. Negative binomial for negative binomial. That is what, by reading the question, you have to identify whether it is binomial, negative binomial, Poisson, or geometric. Because these discrete distributions, I would not specify. But normal distribution in the exam question, it is specified, okay? Okay, let me solve the final problem.
Mike said that no module names, I have to save somewhere.
You have to import it in Python. Okay? Okay, so now what we saw the Z distribution, right? Z distribution like this. This is the Z that has a 0 mean and a standard deviation 1. Understand, right? Now we will solve one problem that has a X with a mean mu and a standard deviation sigma. Are you understanding what I said? Are you understanding? So far, I have discussed standard normal distributions. Now I am going to discuss normal distributions. Clear, right? Okay. One problem that I solved that I am done for today. ACT scores are normally distributed with mean mu and standard deviation sigma. Mean equal to 500. Let me write here. And standard deviation sigma. This is a 6, okay? And this is a sigma. Okay? This is a 6, this is a sigma.
Okay, what is after the mean?
Mu, okay, so let me, with mean, with mean 550 and standard deviation 50. Okay? A student took the ACT exam find the probability that his ACT score is greater than 570. His ACT score is less than 555. His ACT score is between 545 and 565. What score the student needs to have in order to be in 88 percentile? These are the 4 questions I'm going to solve, then we are done. From next week, I'm going to start with the test of hypothesis. Test of hypothesis. Should be fine. Next class, test of hypothesis, okay? You already know hypothesis? Some sorts of. Okay, so let me solve first problem, okay? ACT score greater than 570, X greater than 570. Clear? What is the graph? Graph is this. Let me come draw the graph in the bottom. Draw the graph in here. This is 550 and this is what? 570. Okay, so we need these things. Clear? So in order to do these things, if I subtract that one, then I'll get the value, right? Clear? If I subtract that one, then I'll get the value. So 1 minus probability of X less equal to 570. So which I can write 1 minus states dot norm dot CDF 570, 550 and standard deviation is what? Standard deviation is 50. That is the solution, okay? You can find it, right? Number 2, X less than.
Where did the 56 came from?
What?
The 56.
This is 50. Standard deviation. This is mean. And this is standard deviation. And that one is 555, I guess. Less than 555. Which is equal to states dot norm dot CDF dot 555 dot 550 dot 50. That is the answer. Number 3, 545 less than X 565. The figure for this is that 555, this is 550, this is the figure for that one. Okay. For this one, the figure is this. 545. This is 565. This is what I want to do. So what I do? States dot norm dot CDF 565,550 minus states dot norm dot CDF 545,550. You are understanding, right? So inverse problem. The fourth one is asking you find the value so that it should be 88 percentile. It should be 88. So that means you have to find the A so that this area equal to 0.88. Understand? So now you can write here A states dot norm dot PPP PPF 0.88 550 and 50. That's it. So by 20th of October, you have to take your exam, okay? And then I will assign a new exam, maybe 2-3 days, which you could take by 30th of October on the materials that I have covered. But this exam, this probability exam, it would be sometimes in November, okay? What? 2 hours maybe I don't know. I have to check. Maybe 2 hours or something like that. Yeah, there is a time limit. Okay, I'm going to stop in here. Do you want me to upload this lecture?